Unit 3.2, Lesson 3, Avogadro's number. Chemists use a unit called the mole to keep track of the number of molecules or atoms in a sample. A mole represents an extremely large number. Scientists use scientific notation to express extremely large or extremely small numbers. The mass in grams of 1 mole of atoms of a substance can be found on the periodic table. Called the molar mass, it is the same number that represents the atomic mass, but with different units. As a result of this lesson, you'll be able to translate numbers into scientific notation and vice versa, explain the magnitude of a mole, and define molar mass for an element and find its value on the periodic table. Scientific notation is a convenient way to write numbers that have lots of zeros, either because they are very large or because they are very small. Scientific notation keeps track of where the decimal point should be in any given number. Please remember that when writing in scientific notation, it must follow the form a times 10 raised to the power b, where a, the leading number, is less than 10 but greater than or equal to 1, and the exponent b is an integer. A positive exponent simply means that the new number will be greater than 1. A negative exponent does not mean that the value becomes negative. It is simply expressing a number that is less than 1 but still greater than 0. A number in standard notation can be converted to scientific notation by writing it as a decimal with 1 digit to the left of the decimal point times the power of 10. To convert a number, either positive or negative, in scientific notation back into standard notation, check the exponent to find out how many places to move the decimal point. The sign of the exponent indicates in which direction the decimal should be moved to obtain the correct value in standard notation. In the two examples shown, when multiplying 1.56 times 10 to the positive 4, you have to move the decimal point 4 places to the right in order to get the standard notation. When you multiply the same leading number by 10 to the negative 4th, you move the decimal point 4 places to the left in order to achieve the correct standard notation. Very small amounts of a substance contain enormously large numbers of atoms. For example, 2.2 times 10 to the negative 8th grams of aluminum contains 5.0 times 10 to the positive 14th or 500 trillion atoms. Keeping track of all those atoms, even if you are using scientific notation, is cumbersome. So chemists use a unit called the mole. 1 mole is equal to 602 sextillion objects. 1 mole is also referred to as Avogadro's number. The mole is simply a counting unit. Just as 1 dozen is always equal to 12 objects, 1 mole is always equal to 6.02 times 10 to the 23rd objects. The mass of 1 mole of a substance is called the molar mass. The molar mass of each element can be found on the periodic table. If you want to determine the mass of a mole of a particular type of atom, you can simply look up the average atomic mass of that element on the periodic table. For example, 1 mole of bromine atoms has a mass of 79.9 grams, while 1 mole of potassium atoms has a mass of 39.1 grams. Notice that the numbers for average atomic mass and molar mass are the same, only the units are different. In other words, the average mass of 1 atom of arsenic is 74.9 AMU, and the mass of 1 mole of arsenic atoms is 74.9 grams. So to wrap up this lesson, what is the relationship between mass and moles? 1 mole of a substance is equal to 602 sextillion objects. This is also called Avogadro's number. Because a mole is equal to such a large number, we often express it in scientific notation as 6.02 times 10 to the 23rd. Scientific notation is a convenient way to express numbers that have many zeros. The atomic mass given on the periodic table is equivalent to the mass of 1 mole of atoms of the element in grams, called the molar mass. Molar mass allows you to convert between moles of atoms and grams of atoms. We'll be working more with molar mass to find out exactly what's in a mole in the next lesson.